Yeah, she did.
All right.
I was stopping at that thing like
You have a question or homework? Yeah, you do the last problem. Well, not right this moment, but first time I get through the notes, and then we have time, I'm sure we will. Wait, is this long period?
Yeah.
All right, so here we go. Yeah. Okay, so here we go. We are ready, I think, for problem 5. Is that right? Yeah. All right, so here we go. We've got Milwaukee directly west of Grand Haven. On a foggy night, a law enforcement boat leaves from Milwaukee on a course of 105. So what does that mean? Now remember, it's navigation, so it's measured from north, right? So 105 would actually look something like this. Would you agree with that? All right. At the same time that a small smuggling craft steers a course of 195 from Grand Haven. So 195 would look like this. Would everybody agree with that? They're going to collide. Which my picture makes sense, right? That they're going to collide. And we want to know how fast the smuggling boat needs to be going so that they actually do run into each other. Well, what do we know about the police boat?
23 knots.
So I'm going to call that 23. Now, whatever this speed is, I'm going to call it X. If they're going for 1 hour, then those would be the distances. Would you agree with me? If they were going for 2 hours, then that would be double and that would be double. But the ratios would be the same, so I'm just going to leave it this way. I'm just going to figure out what that X has to be. And that's going to be the speed of that boat. All right, so where do I go from here? Let's find some angles. Can we do that?
Yeah.
All right, how big, I'm going to make it blue. How big is that blue angle right there?
25, 15.
15?
Yeah.
Kids, due east is 90, right? So wouldn't that be 15? How big is this leftover part over here? That whole thing is 195.
65.
So that's 75. Oh, once again, the stars are aligned, because if that's 15 and that's 75, then this one is 90. Chapter 5 is looming, and in chapter 5 it won't be 90 anymore. But right now, it's 90.
All the iterations have to be 180.
And how in the world am I going to find X? Well, it's a right triangle. Can I, let's say, use the tangent?
Yeah.
And say tangent 15 equals X over 23? So whatever 23 and 15 is. I'm not sure, again, kids, make sure your calculator's set in degrees. I don't know what we did last or what you did last year, but make sure you're in degrees. And 23 and 15. How fast that guy going? 1.16 miles, is it knots? Yep, knots. Remember, knots are just nautical miles per hour. That's how fast. Alright, that was interesting. Okay, another navigation. We have a shoreline running north and south. They drew a picture for us. And the boat is due east of the shoreline. So here's our boat. And the bearings of the boat the bearings of the boat from 2 points on the shore are 110 and 100. So we've got 110 and 100. Okay. And this is 550. How far is the boat from the shore? So would you say that's X? How far is the boat from the shore? Okay, what's running through your head right now? Okay, so we can find some angles. Clearly, if that's 110, this one is 70. And if that's 100, this one is 80. And if I want that one, it would be 10. I don't know if I need that or not. And if I wanted this one, it would be 20. Okay, so I've got every possible angle I could ever need. This reminds me of one that we did yesterday. This little triangle right here won't do us any good because it's not right? So we're gonna have to focus on the right triangles. Maybe call this right here, like Y or something. And can we set up an equation that says tangent 10 equals y over x? Is that right? Now, it's not solvable, but then can we set up another equation for the big right triangle? It would be tan 20 equals what? 550 plus y over x. Remember, didn't we have one like this yesterday? What do we do with it at this point? We're gonna substitute or eliminate. I'm gonna substitute. I'm gonna set them both equal to something, probably x, but whatever you want. And then solve it. So go ahead, you and your partner, go ahead. This is an algebra problem now.
Right.
We can solve our brain space. Okay, so I'm gonna do, yeah.
And then are we substituting? Okay, so it's 10 cents. Yeah. I think that's interesting. Oh, yeah, she's oh, X equals all the other. Oh, I didn't find that.
Okay, we started with our two equations. We all had the same two equations to start with. I went ahead and cleared the fractions. So I ended up with x tan 10 equal y and x tan 20 equals 550 plus y. So I just brought the 550 over and now they're both equal to y. Now you don't have to do that. That's how I chose to do it. So then I had my two y things equal to each other. Put my x's on the same side of the equation, factored them out, and divided by the parentheses. And I got that. Anybody else get that?
Oh, yeah.
Now I think yesterday, when we did all that, we came up with what would be y in this case. We didn't get the answer, so we had to go back and change it. But this time, I actually got x, which was the question. So I'm done. Anybody have confusion about that? Okay, well, number 7 is a wussy problem compared to this. Number 7 says that we have a ranger on a tower. So here's the ranger spotting a fire from a 73-foot tower. The angle of depression is 1 degree 20 minutes. How far is the fire from the tower? Now I guess the tricky part about that one is, are you putting your X in the right spot? This is the fire. This is the tower. So when we want to know how far away it is, this would be X, right? Not the hypotenuse. It's this right here. Easy. Sine, cosine, or tangent. Tangent 120 equals 73 over X. So X is going to equal 73 divided by tan 1 degree 20 minutes. So remember how to put that in on your calculator. 73 divided by tangent 1 second angle degree 20 second angle minutes. I got 3136.38 feet. Everybody else get that? That was easy compared to what we just did. All right, what homework problem do I need to do?
The last one, but I think now I can.
So which homework am I looking at?
4-7.
4-7 homework. All right, so this is 4-7 homework, and I'm looking at problem number 5, and the picture is drawn for me. Alright, so here's the picture, looking at the top and the bottom. Theta is formed by the lines of vision, find an expression for theta. Well, we're sort of back where we were on that problem we did a little bit ago. I would love, since theta is part of this triangle, I would love to use this triangle. But it isn't a right triangle. So I am gonna have to use the little right triangle and the big right triangle. So I'm gonna have to rename these angles. So I might call this angle alpha and this angle beta. Just go with me. Call them X and Y if you want, but we are mathematicians, so we're using the Greek letters for the angles, because that's what they do. Now, tell me, let's see, do I know anything else? No. Tell me, I don't know what any of these things, I'm gonna call this X. I got so many variables, I don't know what's going on, but we're gonna figure it out. Tell me about tangent alpha. Tangent alpha is 2 over x. So x tan alpha equals 2, and x equals 2 over tan alpha. Would you agree with that? Okay. Now, I may not need all that, but I get it. All right, now let's look at the big triangle. Tan beta is what? What's the tangent of beta? 14 over x. Yeah, I think I'm gonna stick with this right here. Certainly I could do that if I wanted, but I'm gonna stick with this, and here's why. The tangent of alpha is 2 over x. So alpha is whatever angle has a tangent of 2 over x. Now think about that for a second. If the tangent of the angle is 2 over x, then the angle itself is the angle whose tangent is 2 over x. Would you agree with that? And beta is the angle whose tangent is 14 over x. And what's theta? What's angle? What is theta? Theta is beta minus alpha. So my job is to come up with an expression. Kids, they did not give me enough information to like get an actual like 15.4. But theta is beta minus alpha. So theta is the angle whose tangent is 14 over x minus the angle whose tangent is 2 over x. And there is your expression for theta. Tricky because it's the first time we used inverse functions. I don't think we used them in the other, or in those other problems we just finished. We didn't, but this is one of these. That's it. Now, guys, if you were this museum director, you could measure this distance, right? So if we knew that distance, I'm making this up, but if we knew that distance was, let's say, 30, could we actually find angle theta then? Would it be possible for us to actually find the angle? Absolutely. Absolutely. We can't because we don't have that distance. So this has to stay an expression. Okay? Anything else from that homework before we move on? So the rest of the homework was pretty straightforward?
Wait, one thing.
Good.
4.8.
All right, so 4H's gonna be due Monday.
One quick question. So on number 4, when it says sketch it. We only sketch the part that's a function.
Yep, yep. All right, yesterday I gave you a review sheet that I stole from Mr. Nolan. Mr. Nolan used to teach this class back in the days when Mr. Nolan was here. So when he left, I have a pile of his stuff, and I liked this. This actually was a quiz he gave. I'm using it as kind of a review. And we don't have time, we're gonna do this before lunch. So we don't have time to do every problem. But let's look at 1, 2, and 3. They're the same kind of problem. And Sarah Coleman, which one do you want to do? 1, 2, or 3? It's the sheet I gave you yesterday, 4, 5 to 4, 7. It's in Mr. Knoll's handwriting. You want to do 1, 2, or 3? 2. All right. So we are finding the angle whose secant is 2. Now this is completely up to you, but I don't work very well in secants, so I'm going to think of this as the angle whose cosine is a half. Does that make sense to you? You don't have to do that, but I think in sine, cosine, and tangent. Now, cosine is associated with x, and this is a positive number, so x is positive over here, but the directions say I have to be between pi and 2 pi. So if these are my only positive options, but I have to be between pi and 2 pi, aren't I here?
Oh.
Here's pi, here's 2 pi. I have to be in between them, but I have to have a positive x. That only happens here. Cosine is x. When I say positive x, I'm not talking about that x. I'm talking about x comma y. All right, if the cosine is 1/2, this side must be negative √3. And how big is this angle? 60 degrees. But I gotta be in radians.
Negative pi over 3.
So pi over 3. Now that's my reference angle. So now I gotta go back and look at my directions. Whatever you write down as your answer, guys, has to be between pi and 2 pi. Right? So could I name this negative pi over 3? I absolutely could, but that doesn't fit. So how am I going to name it then? 2 pi minus pi over 3, which is 5 pi over 3.
I looked back there and I couldn't find it. Is it in school, G?
No. It should be in the honors. I put the extra copies in there. It should be there.
Okay, I just
Sorry. Grab somebody's and make a copy, or I'll let you make a copy, or take a picture. Grab somebody's and take a picture. Okay, find the exact value without a calculator. Okay, 4, 5, and 6. We're gonna do one semi-par. Which one are we gonna do, 4, 5, or 6?
Let's do 6.
All right. Now, don't let, this notation, oops, let's see now. That notation we don't use very often. Remember, this is the same as this, right? I don't care, it makes no difference to the answer which way you think of it, but if that is confusing you, you can think of it as this. So what is this asking me to find? find what? Find the angle whose cosine is the tangent of pi over 4. That's what it's saying. This says find the angle whose cosine is that. So what am I going to do first?
What's your tangent?
I'm going to find the tangent of pi over 4. And I'm going to do that. If you have it memorized, great. If you don't have it memorized, you're going to think, well, let's see, pi over 4 is 45. And the tangent of 45 is 1. So this is saying find the angle whose cosine is 1, because this is 1. Now, this notation automatically means that you are looking only at this part of the circle, right? Inverse cosine, quadrants 1 and 2, 0 to pi. I want you to think about that number for a second. Cosine is adjacent over hypotenuse. Is it possible to have a triangle where adjacent and hypotenuse match? No. So if we can't draw a triangle, then we have to be looking at one of these points. It's the only other option. So where, these are my only options here, these 3 points, which of those 3 points has a cosine value of 1? 0 degrees, or 0 radians, that's exactly right. So the answer to the problem is 0. Right here. This cosine is 1. Because cosine is x over r. The radius is 1. 1 over 1 is 1. That's the point. Whoa, that is mind-blowing. We may do another one of those after lunch. We'll see. Back in your seats at 50. Promptly in your seat at 50. Not going to the bathroom at 50. In your seats. Jelani Jones.
Yes.